The surface of Earth is like a giant puzzle, and all the pieces that make up this puzzle are called tectonic plates. Although these giant rock puzzle pieces fit together very nicely, they don't stay in place because they're floating on the layer below us, the mantle. This layer is like the consistency of silly putty, sort of like a liquid and yet sort of solid too. The plates float around on the mantle like ice floats on a pond. The movement of the plates is incredibly slow, but since the plates are so big, when they bump into and rub against each other, we get massive events like volcanoes and earthquakes. And along these plate boundaries we find faults. Faults are cracks in the Earth's crust where movement occurs on at least one side. So in order for a crack in the ground to be a fault, one side or the other has to move, but sometimes both sides move too. Faults are classified by how they move, and there are three main types of stress that cause movement along faults. The stress occurs because, as mentioned before, the plates fit together really well, but also float around on the mantle and rub against each other. Tensional stress is when slabs of rock are pulled apart. Imagine stretching a rope out all the way and then continuing to pull on it from both ends. You're putting tension on the rope because it's being pulled in opposite directions. The same is true for tensional stress in rocks. Compressional stress is when slabs of rock are pushed together. They are literally being compressed into one another. This is like when two cars crash into each other. They're compressed into smaller, crumpled versions of what they were before. Shear stress is when slabs of rock slide past each other horizontally in opposite directions. The rocks are not smashed into each other or pulled apart, but their edges slide along each other with a lot of friction. This is like when you rub your hands together to warm them up. One hand goes forward and the other goes backward, rubbing against each other. The type of fault we get depends on the type of stress that caused it, which also tells us about how the fault moves. Faults have two sides, the hanging wall and the footwall. These terms were coined by miners because you can stand with your feet on the footwall and hang a lamp on the hanging wall on the opposite side, and the reverse situation would be impossible. Tensional stress, meaning rocks pulling apart from each other, creates a normal fault. With normal faults, the hanging wall and footwall are pulled apart from each other, and the hanging wall drops down relative to the footwall. Most of the area just west of the Rocky Mountains is affected by normal faults. Places like southern Oregon, southwestern Idaho, eastern California, western Utah, and the entire state of Nevada. Compressional stress, meaning rocks pushing into each other, creates a reverse fault. In this type of fault, the hanging wall and footwall are pushed together, and the hanging wall moves upward along the fault relative to the footwall. This is literally the reverse of a normal fault. The Rocky Mountains, the Canadian Rockies, and the Appalachian Mountains are all examples of the types of features created by reverse faults. Shear stress, meaning rocks moving horizontally against each other, creates strike-slip faults. There's no vertical movement of either the hanging wall or footwall, just horizontal movement of each side of the fault. You can think of this like striking a match. You have to strike it horizontally along the strip to get it to light, and once it does that slip, you get a sudden flame. Strike-slip faults are very similar. They slide past each other, and at the right moment, if there's enough friction that they get stuck, they suddenly slip apart, causing very powerful earthquakes. The San Andreas Fault that runs through California is one of the most famous strike-slip faults in the world because it's so large and causes so many earthquakes. Earth's crust is broken up into tectonic plates, which are like giant puzzle pieces made of large slabs of rock. The places where movement occurs along the plate boundaries are called faults. Faults are the large cracks between plates, but not just any crack can be a fault. There has to be movement along at least one side of it. Three types of faults are caused by three types of stress. Tensional stress is when rock slabs are pulled apart from each other, causing normal faults. With normal faults, the hanging wall slips downward relative to the footwall. Compressional stress is when rock slabs are pushed into each other, like cars in a head-on collision. This causes reverse faults, which are the reverse of normal faults because in this case, the hanging wall slides upward relative to the footwall. Shear stress is when rock slabs slide past each other horizontally. There's no vertical movement of either the hanging wall or footwall, and we get a strike-slip fault. These rocks move like your hands do when you rub them together to warm up. The movement along faults is what causes earthquakes. Some faults are more active than others, like the strike-slip San Andreas Fault that runs the length of California. Others are known for their mountainous masterpieces, like the reverse fault activity that created the Rocky Mountains in North America.